I don't know. I have to look at 0 to 2 first. I have no idea what they mean by all x. I mean, by all x, we mean all real numbers. Okay, so we're told that f prime of x is less than or equal to 4. If I'm told that, again, like before, I'm told the function is continuous and differentiable. And I'm assuming that first, since I have f of 0 and f of 2, I'm looking at the interval 0, 2. If the function fulfills these conditions between 0 and 2, then, like before, f prime of x of c equals f of 2 minus f of 0, similar to what we just did a minute ago. 2 minus 0 will be less than or equal to 4. F of 2 is given to us, which is 8. F of 0 is given to us, which is negative 6, and divided by 2. So this is 14 divided by 2. Well, 14 divided by 2 is 7. Is 7 less than or equal to 4? The answer is no. So there is no such function that fulfills the given conditions, not even on 0, 2. Good, this was section 4.2. Would you like to go to 4.4, which is more of L'Hopital's rule?
Seems like it would be helpful.
Okay, what about problem 12 in 4.4? Is that something you are interested in? What about 15 or 16? Which one?
12.
12. Let's go with 12. So we have 12 from Weber-Sine. We have limit as x approaches infinity, x sine 8 pi over x. Remember, we have 7 indeterminate cases, and only 2 of those are acceptable for L'Hopital's rule. But we learned that the product is friendly, the powers are not, and the difference not something that I would try with L'Hopital's rule. So let's see what situation we have. When x approaches infinity, this approaches infinity. When x approaches infinity, this approaches 0, and sine also approaches 0. So this is not a very cumbersome, it shouldn't be a very cumbersome situation. Why? It's because it's a product. So the product should be okay. Okay, so maybe, as we discussed last time and some other situations, an algebraic manipulation will help. And it will. 8 pi over x over 1 over x. So I changed x into 1 over x in the denominator. Is the same thing, just a simple algebraic manipulation. When I divide by a fraction, I have to flip the fraction. And now this is nice because this is approaching 0 and the top and bottom approach 0, which is a convenient situation for L'Hopital's rule. So now, limit as x approaches infinity. Remember, this is very useful. We discussed that several times. The derivative of this is negative 1 over x squared. And then when I differentiate sine, I do get cosine of 8 pi over x, and I multiply by this prime, which is negative 8 pi over x squared. Luckily, the negative 1 over x squared or 1 over negative x squared with this will go away. This will approach 1. So the only thing that is left is the 8 pi. Because there is a negative 1 over x squared with a negative 1 over x squared, and there is just an 8 pi left.
I've forgotten a bit on how we determine that cosine 8 pi over x is going to 1. I just need like a brief question.
Oh, sure, because this approaches 0. When x approaches infinity, this approaches 0, and cosine 0 is 1.
Okay.
Better?
Yep.
Okay, this was 12. Is there anything else that you would like to look at, like maybe 15? That's a power situation. So you get another example of that.
Let's take a look at it.
Okay. Uh, 15, we said, yes, limit. But that's the 15 I see. So as x approaches 0, 1 minus 6x raised to 1 over x. Again, we have to check that indeterminate case we are looking at. And we realize that this approaches 1. And we realize that this approaches infinity. So it's 1 to infinity. Okay, so then my only option here is to denote this by this. Apply natural log. And now apply, so this was step 1, this is step 2, and now in step 3 I apply the limit to both sides. Limit as x approaches 0 from natural log y equals limit as x approaches 0 from this. Which is sweet because the numerator is 0, the denominator is 0, it's already set up for us to apply L'Hopital's rule. And next we have limit as x approaches 0. The numerator is 1 over 1 minus 6x multiplied by negative 6 divided by 1. And when this approaches 0, the final answer is negative 6. Now in step 4 I have to copy the beginning and the end, which is limit x approaches 0, natural log y equals negative 6. And remember at this step we swap the two operators. So I have natural log of limit of y when x approaches 0 equals negative 6. And now I'm ready to write what this equals to. And now I go back and replace y by 1 minus 6x to 1 over x. And this will be the final answer. This raised to this is this. So what is the final answer? What is the base here?
The e to the negative 6.
Very good. So that's why this is a complete indeterminate case. No one knows what it leads to. Let's see other sections here. Is there anything else you would like to go back to? You do not have to cover 4.6. You don't have to spend time on it unless you want to. It's graphing with calculus and calculators, so, but we do that all the time. Let's see, there are 5 problems in there. You can skip that. Good. Any other section you would like to go back to?
Could we do one more example from this section? Doesn't necessarily have to be from WebAssign, but similar to the
Which section? You mean L'Hôpital's role?
Yes.
Oh yeah, sure. You want to choose? They are on page section 4.4. Page 308. 15 through 66.
How about one that's a little simpler than, I'm not sure which one would be
So
considered.
you don't want the power.
Sure.
This is what we just did. This was the power. You want something easier than the power. Is that what?
Yeah, I recant. Let's do one with that has the power, because I'd like an example of doing what we previously did.
Okay. So I don't remember right now which ones we did and which one we didn't. Not sure whether we did cosine to 1 over x squared, the limit. Did we do that one? Did we do 2 minus x to tangent pi x over 2? 64, 66. Would you like to choose, or I will, or?
Yeah, I think, like I say, you always pick the best ones.
Thank you. Okay, I will pick I'm sure these both are interesting. So let's try 66. Oops. And this is on page 308, and we have limit as x approaches negative infinity 2x minus 3 over 2x plus 5, and everything raised to, what power is that? 2x plus 1. And it's not negative infinity, but it's positive infinity. And that's correct, 2x plus 1. Perfect. Okay, so with this problem, like always, we have to see what the type of indeterminate case we have. And I have to study this first. Obviously, this approaches infinity. There is no discussion there when x approaches infinity. But I need to discuss this, because I don't know what limit as x approaches infinity from 2x minus 3 over 2x plus 5 represents. Yes, we do from pre-calculus, but let's say we don't. It's infinity over infinity. I will apply L'Hôpital's rule. The top is 2, the bottom is 2, so it's 1. So this whole thing approaches 1, so again we are facing 1 to infinity, like we did a few minutes ago. So I will denote the function by y. So we have y equals 2x minus 3 over 2x plus 5 raised to 2x plus 1. In the next step, I have to apply L'Hopital's rule. I'm sorry. I have to apply natural log first. Do not forget to put 2x plus 1 in parentheses and natural log 2x minus 3 over 2x plus 5. And now we differentiate both sides. So first we denoted the function by y, then we apply natural log, and now we need to differentiate both sides. You know what I mean? I meant the limit, of course. This is not implicit differentiation, sorry. So limit as x approaches infinity from natural log y equals limit as x approaches infinity from 2x plus 1 natural log 2x minus 3 over 2x plus 5. Okay. Now I check again what indeterminate case we're facing. Let's take a look. So this approaches infinity, and what happens here? This approaches 1, as we just did that, and natural log 1 is 0. So this is a more human situation. It's 0 times infinity. So from the power 1 to infinity, applying natural log, we reduced it to the product. Okay, so now we have to algebraically manipulate this product to get into 0 over 0 or infinity over infinity. As I mentioned many times, do not touch the log. That would be a terrible mistake. So natural log stays at the top, and I will change this like we did a few minutes ago into this. Are these two functions the same? Yes, they are, because when I divide by a fraction, I have to flip the fraction, and that's what we get. Okay, then, so now I'm ready to apply L'Hopital's rule because the numerator is 0 and the denominator is 0. I mean, the numerator approaches 0, the denominator approaches 0. Okay, ready? Before I do that, I think I'm going to change this into natural log of 2x minus 3 minus natural log of 2x plus 5, and I'm going to change this into 2x plus 1 to negative 1 because it's easier to differentiate. So I'll differentiate the top now. And I get 1 over 2x minus 3 times the inner function prime minus 1 over 2x plus 5 times the inner function prime. And careful now, careful, careful. I bring down negative 1. I subtract 1 from the power, and I multiply by the inner function prime. Nice, all these 2's will go away because I factor 2 from the top and I simplify, but I'm going to write it for everyone to see. Limit as x approaches infinity. So 2 find the least common denominator in the numerator is the product 2x minus 3 and 2x plus 5. This piece needs a 2x plus 5 and this piece needs a 2x minus 3. So 2x plus 5 but minus 2x and plus 3. It's all algebra right now. So limit x approaches infinity. These two go away. The numerator is 8 over 2x minus 3, 2x plus 5 times. Now this is negative 1 over, so I have to flip it. So I'll put the minus in front. So this was 1 over 2x plus 1 squared, so now it's 2x plus 1 squared. It goes to the numerator. Negative 8 can wait outside patiently. And I don't like to do this, but I will this time. I will expand this as 4x squared plus 4x plus 1, and I will also expand the denominator as 4x squared. 10 minus 6 and minus 15. And yes, this is infinity over infinity, but you know what happens when we differentiate. All this will be 1 because it's 4 over 4. But let's say we don't remember that. So we have 8x plus 4 over 8x plus 4, which we know is 1, so the answer is negative 8. After all this work, I have to copy the beginning and I have to copy the end. So the beginning was limit as x approaches negative infinity from natural log y, and the end is negative 8. We know what happens now. I have to swap the operators. And that's our final answer. So then this is e raised to negative 8. So limit as x approaches negative infinity, and the function was of 2x minus 3 over 2x plus 5, and everything to 2x plus 1 is e to negative 8.